I'm going to be talking to you about 25 years of celebrating the National Science Day at the Giant Microwave Radio Telescope. And as it's one of the most sensitive radio telescopes in the world, as you will see, it's a rather large enterprise, so it's not a one-person job. There's a huge team which works on that. So I'm presenting this on behalf of the entire team. So in case there are people in the room who are not already familiar with what GMRT is, well, it's the Giant Microwave Radio Telescope. As the name says, it's giant. It has 30 antennas, each one of which is 45 meters in diameter. I hope many of you have signed up for the visit to GMRT on Sunday, so you will get to see that, those majestic antennas yourself. There are 30 so this is like a 15-story building. The diameter of that, just to sort of relate it to something familiar, there are 30 of them. They are spread over a region of about 25 kilometers, arranged in the shape of a Y. Located about 80 kilometers north along the Pune-Nasik highway, it takes 2.5 hours to get there. It was dedicated to the astronomy community in the year 2001. And about 20 years later, it completed a massive upgrade. So basically, apart from the concrete of this tower and the steel of this dish, everything else has been upgraded. So all the electronics, right from the front end to the back end, has been upgraded, and that allows us to stay one of the most sensitive radio telescopes anywhere in the world. In fact, in this frequency range, which I did not actually talk about, so this is a little higher than FM, goes all the way up to the frequencies which Duncan was talking about yesterday, 1450 megahertz or so. In most of this range, GMRT is the world's most sensitive radio telescope. So in the roughly 25 years it has been in operation, it has provided data to more than 4,000 astronomers coming from more than 40 countries and has led to about 1,000 or so refereed papers. National Science Day, again, this audience already knows, it's celebrated every year on the 28th of February. At the GMRT, we make it a two-day affair. So 28th Feb and the day after. We think it's perhaps the largest science festival of its type, certainly in rural India, because it invites, or we have footfall somewhere between 20 and 25,000 over these 2 days. These are just to give you a little bit of a glimpse of what it might be like. I have a video later on which will do a better job than this. So why did we want to celebrate the National Science Day at GMRT in the first place? This is one of the early science days. There's Govind Swarup himself, inaugurating the science day. This was the then director, Professor Rajaram. And again, Rajaram sitting here at Ask a Scientist booth, which is one of the most popular ones. So when we started, this was really about demystifying GMRT, right? We had sort of moved into that place. It's a very rural area. A lot of farmers had given their land for this project, and they had no clue what does this project do. There were also a lot of misinformation, like these giant antennas are sucking all the rainwater out of the clouds. That's why we are getting less rain. Right? From there to the radiation from these antennas is going to have an impact on our lives, on our crops, whatever. Right? A radio antenna doesn't emit anything. It tries to keep everything quiet so that it can quietly receive whatever it is. So it started from there, and also to satisfy the curiosity of people. Right? They see these giant structures sprouting all over the place. Naturally, they are curious about what is it that's happening here. We wanted to take the opportunity to introduce concepts from basic science, relate them to astronomy, tie them to radio astronomy. Radio astronomy is a little less intuitive, right? The telescope doesn't look like a telescope. There's no place where you can put your eye and see. We don't have fancy images like Hubble or anything to show, even though we call ourselves a world-class facility. So it takes a bit of explanation to say why do you need a radio telescope, how does it actually work, what is the science it does, what do you produce in terms of data. And also use the opportunity to promote scientific temper in the area. Right? There's a lot of youth there who has no access, unlike in urban areas, to various other science festivals or talks or whatever. Anyway, this was pre-internet. So to try to have a conversation with these people, especially the youth, about promoting scientific temper, share with them, what is it really that excites us about the work which we do there. And also counter the narrative which we often build ourselves that the best science is being done somewhere else. Right? You hear or you read more press releases from NASA than you read from Indian science. enterprise. So to show that here, right here in your neighborhood, we have the world's best facility, we're doing cutting edge science, we built it ourselves, to promote that sort of a narrative, that was another reason. And we were hoping that this would also inspire some of the kids who are walking in through that to think about it a little more, right? To at least include this in the realm of what they consider their opportunities to explore as they grow up. And of course to build our own science communication skills, right? Scientists in India are not taught how to communicate their science. So we wanted to use this as an opportunity for ourselves, for our students and postdocs to learn how to communicate what you're doing to people. As we've sort of gone along, we have added more to that. It started by us trying to tell the visitors who are coming here to GMRT. Now we have a very large component where we want the people who are coming to GMRT on the National Science Day to talk about what they have been doing. Right? So we have, this has become a very large showcase of science projects from schools and colleges all around the Pune region. Last year we had people from as far as Goa who had traveled to showcase their engineering projects here. And because this has been going on for a while, many schools and colleges, they conduct their own science exhibitions, and the winners from that are what are sent here. And it has become very prestigious to present your projects here. We also invite students from Ferguson College and ISER Pune to work with us as volunteers because we have 20,000 people walking in. We need more people to explain to them what is it that we do. So we first train them, and then they are out there in the field talking to the people who are walking in. We also, given that we have such a large footfall, we wanted to share this platform with others who might find it useful. Right? So there are lots of other research organizations. There are some departments from Pune University, Department of Geology and Geography is one. There is National Chemical Lab, there is National Institute of Biology, and a few, other organizations like Free Software Foundation and so on. So many other NGOs who are working, NGOs as well as education institutes and research institutes, which are working in, sort of related areas, who would also benefit from a large audience to whom they can convey their work. We started to work with them. Past few years, I think more than 5 years now, ISRO has been setting up a big pavilion. It's always a big draw and attracts, not just youngsters. Last year I was talking to 3 generations of a family from the same time, and the driving force who brought them here was the grandmother, right, who really wanted to see what this thing is about. She had just read about it in the newspaper and was really curious. We have lots of demos which try to bring science to life. This is showing you the stationary waves in a tube. You can see the pattern in the flame quite nicely. And we have data and astronomy demonstrations which are going on all the time. COVID forced us to introduce an online component that we have been so happy with that we continue to do it even though COVID is gone, but that has been something very nice for us here. So in terms of numbers, like I said, we've been running for more than 25 years. Our footfall is between 20 to 25,000 over the 2 days. We have roughly somewhere between 80 to 100 colleges which participate in every edition, or 30 or so other organizations who are invited to be a part of it. Last year we got more than 900 projects and 80,000 views online for the projects which were submitted. This has really expanded our reach beyond our local geography, including last time from Middle East. You'll hear more about it in Nilesh Chadavilkar's talk tomorrow at 11:30, so I invite you to be there. Here is the movie which I wanted to play, because that, okay, well it thinks it is playing. Okay, when I tested it earlier, it was working fine. I have the file. Okay. Yeah. Because a visual does a lot more than what I can do in terms of words, right? So this is something which was put together by our volunteers last time at the Science Day. So these are the school students just walking in. Here are the stalls which they have set up to showcase their own science projects, so which are looked at not just by the other students, they're also evaluated by our, a team of teachers teachers and our staff members there. We have, of course, our own people who are talking about the displays from the GMRT, the antennas and various other things. These are some of the engineering displays which you are seeing here. So each of the labs sets up, displays about their own subsystems and tries to talk about how the whole thing comes together. And of course, we have an Ask an Astronomer stall, which is always very crowded. Your throat is really parched by the end of the day. We have lots of posters which talk about various concepts from astronomy, astrophysics. This is the ISRO stall I was talking about. This is another very popular feature. This is a group from PIFR who come every year to showcase some of the experiments. What is very heartening to see is that some of these projects which are there, they are really trying to solve the local problems which they are facing. Right? It's from an automated way to organize irrigation in the fields, to soil testing to figure out what nutrients do I really need for specific crops in my area, right? To more futuristic things about traffic organization in the cities and so on and so forth. These days there's a lot of use of machine learning in the projects. That particular project was about recognition of faces. And as you can imagine, there is a big behind-the-scenes effort to put everything together. We work with the Pune Municipal Corporation to run buses from Swargate to this place because it's an out-of-the-way place. It's hard to reach, right? So you have to make it easier for people to reach there and travel back. So it's a lot of effort to do that. That I think is the end of the video, and that I'll let the credits play so that you know who are the people behind making this. So that's Kaushal and Kshitij and Shil Kumar from NCRA who did that. And even though this is a lot of work for us, even though this is not something we are really staffed for, it's a stressful time, but we really find it a very satisfying and exciting enterprise. We really look forward to that every year. This is one of the few things, so maybe not one of the few things, but it does really bring the entire observatory together to work for a common purpose, because in our hearts everywhere somebody does want to believe that science communication is something really important for us. I believe that it's the participatory nature where we also invite people who are coming in to talk about what they are doing, which makes it special for them as well. I think for us, it's a small way to contribute back, right? Like Duncan was pointing out yesterday, we live on taxpayer money. So that's one of the things we want to work towards as well. It helps us strengthen our relationships with our neighbors as well. Right? That's an important thing for us. With that, I will stop and I'll take any questions which might be there.
Definitely makes a point that we need to have more science melas and fairs and things like that. Jatras and fairs all the time, but only with religious aspect or cultural aspect we can have more science. Next this is to activities. Again, and I'll be glad that it's seriously clear time 10 minutes or 20 minutes, and then you have a little bit of interaction. I'll give you the last slot because it will take time to
Basically, I'll start. So, whenever we go to the title itself says that activity related demonstration for astronomy or teaching, for example, I have seen so many tasks also, like we always have the say this is open to the this is open to the PPT or GPT? Yeah, so no, it's not correct. So we have Bhaskara with the main activity-based demonstration, and last talk also in we heard that some of the things we bring here. So it always happens. I also experienced, and when I am took the for this very outreach, and when we are visiting the government school and all the schools, and we cannot expect a place like some of the demonstration things or anything together. So I try to manage with the people with respect to whatever the availability of can I stop? Yeah. Okay. How can I open that? No, so it's compiled. It has more so that case I used to go with the people and whoever audiences are there and activities. I follow the reason, and with respect to them, my demonstration, I do some of the things. Explaining. Oh, it's not reading.
Maybe we use the slides to
Some context that I need to hear. Okay, so some of the things we can address by activities. For example, this is more good with the interactive, but I'm just going to the point. For example, these are the questions we can address, where we know that the sun is moving, that direction everyone knows, but when we are asking question about the night star, people will give a blank, and other eclipses and the motions and everything. And basically, with the observatory, we have a museum. So we, for football visitors, almost like 60,000. So some of the things, for points where we have limited infrastructure, that we need a creative and low-tech approaches, some activity-based demonstration, which is making similar. So these are the points zero gravity, eclipses, and everything which can reach for all the audiences also. Because the audiences we may not know each other. Sometimes school kids and college people, so I always go with this one. For example, whenever we are saying, suppose there are people are sitting on it, and he's supposed to explain to the people, but okay, I am going with the audiences. I go with the audiences. So when I am moving from west to east, so automatically let us assume I am traveling the terrain and looking around the people through the windows here, and we indicate that all the nearest trees moving in the opposite direction. Okay. So this is the easiest method. I don't bring any demonstration activities or nothing. I'm just explaining the people itself, where the people are sitting on the road, and just by moving, and you can say that. So this is exactly equal to the earth rotation. Okay. So if you take an earth rotation, I can stand like this, north and east and south and west. So when I am rotating from west to east, okay, there are phases on view. Okay, the other thing is east to west. So when I am saying that west to east rotation, so automatically I will ask some person to stand. So when we are standing, so it is easily visible that the person is rising in the east and setting in the west. Okay. So this is easy to explain. Okay. So then. Yeah, so this is the way we can say that. So whatever you are seeing in the daytime, that the sun is rising in the east and setting in the west, so it's nothing but the earth rotation makes that apparent motion. Okay, so the sun is rising, appears to be rising in the east and setting in the west like that. Then when we ask the same question, the night sky stars, people always get blank and they couldn't answer because they never know. Sun, daytime we are watching, okay, sun is moving in east to west, but nighttime the answers are always the keeping moment. So this is again you can say that. See, night also the same. So the same concept. Now one person standing in the sun, like assume that the number of people sitting in the audience or the school or class students where they are sitting, we can say that you are all the stars. Now I am rotating, so the same thing. West to east I am rotating, and all the people are rising in the east and setting in the west like that. So this is just for checking purpose. I noticed with all the class students like school to college and all that. They always I never get answers for the night time. So I can say that stars, night time stars also follow the same. It's nothing but we are the one rotating. The apparent motion looks like appears to be rising in the east and setting in the west. And another question I will take with whatever other negative meaning. I will say that we know that as per top one, this is the clockwise. Okay, that is basic example. And I separate the audiences as two different chats. Then I will say that I will check. Suppose this is the object I am rotating, and what kind of rotation I am rotating, whether it is clockwise or anti-clockwise. So if you notice, so one of the people, we know that this is clockwise for these people. When the audiences are looking from my hand side, this is clockwise, but when it is going the other way around, it is like anti-clockwise. So, sorry, with the other one. So, let this slightly, it is that, but I will go with the bracket. You can previous weapon. Okay, you start it's a video. Finally, I compared as I animated, so I am going with the slide. So what I try to say is, so easily we can separate from this audience to this audience. So we can start up with the explanation of solar system. So whenever we are explaining seasons or anything, whether we go to the Google images or anything, they never talk about the which way it is. For example, when we are looking at the solar system from the upper view, it is like a counterclockwise, where it is the bottom view that is clockwise. Okay. So for example, if you see this one, here March and June and September and December. So this is so first we are explaining that any of the objects separating the audience just by rotating. So that the line of sight is very important to say that whether it is clockwise or anti-clockwise, and then we can go with the explanation of the seasons. And here also one of the questions, like the initial slide I have asked, like people can answer that. Which one is nearby? Like for example, June we always feel like a heart, and December we feel like a pole. But purposely I made this one, and some of the things I have to customize still. So here if you see the distance is small, and here it will be like a large one. And always when we are asking the question answer will be the wrong. Like this, we are feeling so old, so December will be farthest December distance, and June will be the nearest one. But nothing like that. It is the angle matters because the orientation matters. Although June is far, it is orientation towards the sun. Although the December is here, the orientation away from the thing. So this one we can explain with the showing our hands like this. Okay, like relation. Otherwise we have to make an angle and saying that orientation of the thing. And this particular thing explains about the zero shadow. If you see that it is especially for our area. Like starting from -23 and up to +23 and up it happens. So if you see that two times it comes, one is the April and one is the August. So here, if you see that another picture, so here assume like this is futuristic, you can say that so okay. So that picture you see that while orbiting around it, so we can say that the center portion, wherever the equinox stand, the sun rays are exactly falling on the equator, and slowly when it is going on March to April, and then June and July, August, like that. So slowly it is increasing to 1 degree, 2 degree, and the rays falls on. For example, it is something like we go on the Bangalore in 12 degree latitude. So we can see that while rising up and again 0 to -23 and while going down, the sun rays fall, so that exactly 2 times it is happening like that. Then another explanation. So this is very good with the activity based only. We are calling the people. We no need to bring any of the model or anything, just by the people. And always whenever we are explaining about the Aditya L1 or any of the payload meaning, so people always bring with what is mean by L1. So again he can explain the number of people, calling that this is like a red color version. With respect to, if you notice all the pictures are created with respect to the dresses, with respect to the color, like someone is wearing red color, we can all the sun, and another person blue color is here, and some of the common people, similar school dress are anything like 5 people for the Lagrangian mind. So this is 1 and 2 and 3 and 4 and 5. So we can explain and we can say that see this is a L1 where Aditya L1 is sent, and it is almost like 1% of the district between sun and here. And again always the question comes with the eclipses part. So where while explaining the eclipses, people have a doubt, the visual always the memory, whenever I am asking them the question, the memory always goes to the, the answer always goes to the memory, they think. So I will always ask them, don't take it, go with the practical. Let's asking them 3 people to stand here, like one red color shirt, here as a sun, and here one blue color person as here, and another white color dress as a moon kind of thing. And whenever we are asking what phases the eclipses occur and what type of eclipse it is, so people always have a doubt to explain. So we can say that ultimately like the sun is nothing but one person is looking at dark side and focusing on this person is supposed to be directed towards the thing. But I'll make the people to stand on where yet and moon person always facing each other. So it's highlighted of explanation. So people always have a doubt with what type of eclipse it is and why is that occurring like that. For example, this is lunar eclipse. So lunar eclipse, you can see that the person, so the light is coming, but the shadow falls on it. This eye is towards where you are looking kind of thing. So that here also people always have a doubt with which phase of the moon is happening. So you can say that sunlight is falling. So logically, of course, this is a full moon time. And when it is coming, it will get a thing, and then it will be so the eclipse goes like that. So again the question comes like the previous picture you think over here when the moon was here. When we are passing the light, this portion will be the brighter one. When we get to the point of it is dark one. So it is basically new moon. So after explaining the new moon and the full moon, we can say that then why after the eclipse is not occurring. So of course we know that the 5-day period. So that is what the reason. Then that also can be possible without anything, just by the steps. So we can ask that to scan one person, and it can be like 5-day assumption, and we can ask another person to climb on things. So these 2 points like assessing descending, 2 nodes are the joining points, where exactly when you are matching the sun, easily the eclipse, those are the points where the eclipse is occurring like that. So unfortunately now it's not and another complex system, mathematical explanation of the RBC number like celestial sphere and celestial equator. This is again very easy. Like assume that this is the blue color person is there and this is the sun. Either we can have an imagination of sun when the sun is the center and the earth is the inclined thing. So, but our illusion, our assessment is always the other way around. Like where the earth is the center, where the sun is the inclined angle. Either you can change the person or you can make it the orbit. These are all, we know that over is going to the celestial planets and the mathematical concepts. It is always a bit complicated, but by the people itself we can understand. And in simple, we can say that we are in the world where the heliocentric, sun is the center where everybody is orbiting, but we are looking as a geocentric. So that can be explained by the people itself. And as we can make them that we can ask the question that see, look at the seaside, beach side, where if you know down the sun, rising point, it is not always the same. It is another you not only the exact March and September, exact east and west. The other thing is go to the Uttarayan and Dakshina. I mean, along that can be explained. After we made a center and after explaining the seasons, and when we are two dimensions and holding as a one, we can explain to the people here. So this is the like we can rotate and so. Like this, and when I am going this side, of course sun moves on that side, and after June, July, September, and August, December, I am rotating, it goes on the other side. So this is an easy explanation for explaining the thing. So yeah, so thank you for this thing. So the summary is nothing but all the motions. We are living in the illusions like the other way of understanding the visual perception. So in the place wherever you are reaching, where you might take a demonstration or activities, or suddenly you are addressing the village or any of the schools without anything, no need to worry. The monotonous of PPT talks, sometimes students will get bored or they may not catch. So activity based always they will be interested. So just we can manage the number of people who are there with the color code dresses also, red color and sun and blue as the air and the white as the moon like that. Just to buy the people we can manage and we can engage with the that's thank you.
The chair personalization will just be me, so you have to come with your slides. Probably like 2 minutes.
Hello everyone. Hi. So to start, hopefully I'm audible. Yes. Okay. So I'm the senior coordinator of the library project, and I'm going to be talking about how we communicate library and gravitation. Hence the name comes communicating the whispers of the universe. By now, whatever astronomy we have been studying and also discussing in this symposium is mostly about the electromagnetic counterparts. But since the discovery, since the first detection of the gravitational waves in 2015, we also started to hear the whispers of the universe. So here we go. So short introduction about LIGO project. LIGO is a gravitational wave observatory which we are building in Mongoli. It's been built by 4 institutes: IUCAA, ARACAT, DCSM, and IDEA, and it's supported by 2 government institutions, DE and DST. So if you want to know more about this project, you can discuss it at Bhaskara and Foil, and I'm standing over there. We have model posters around. So why did we communicate LIGO and gravitational waves? The first one is to create awareness among the people of Mongoli. So Mongoli is the place where we are building it. So it's necessary, as we heard in DMRT, also it's necessary to communicate with the people who have given their lands for the project. So it's for them. To encourage students to also specialize in gravitational wave astronomy and idea to train undergraduate students in professional skills, multidisciplinaries related to gravitational science, promoting women's participation in STEM, and especially in gravitational science, we also promote them to join LIGO collaborations.
to cultivate general interest in astrophysics and astronomy. This is for the general audience and non-academic people. So we do this as multiple steps. So let's start with outreach in the library side. So the reason behind outreach at library side is to connect the local population, communicate gravitational waves, to curb this information, providing them learning opportunity. So this is one important part is, since we are building something over there, we have to give them something, right? So we also provide them learning opportunities over there, so that they also participate and they also feel included in the project. And then the next is to cultivate interest in astronomy and astrophysics in the whole district. So we do this in 4 steps. First, rural educational level outreach, which is about discussing the locals, creating content in Marathi. Now, Hungary is a district in Maharashtra, which is primarily Marathi is the mother tongue. So we have to communicate in Marathi and for visiting schools. Then we also have the teachers training workshop, providing them with the right information and also with the educational materials which they can use to discuss with their students. So what we expect is that the students will communicate with their parents, something like, hi mom, this is today you have a discussion in the school and this is how I get it going to be. So usually the kids are the ones who discuss. Then we also have learning, also provided them with learning opportunities. And we also host annual fests like annual events like Starfest. So starting with Himalayan outreach, rural and educational level outreach. So we interact with the Jilla Parishad schools. Now, especially for the Jilla Parishad schools, so what we do is we visit them. Now these schools are small schools, especially primary level schools, which do not have, so whatever the access that they have is from the government, supported by the government. And when they have people from academia or the researchers coming to the institute, they feel encouraged. We also interact with the girls students. You can see a photo over there of the girls students. So we also interact with the girls students so that they feel included and they get inspired about how they can join from a rural place, from a small rural place to a larger collaboration like the life and collaboration. So there's a video, I am not sure if that play, but okay, fine. So that's so we also visit the APJ Abdul Kalam labs. These are small labs set up by the teachers over there and by the government over there. And these labs have small robotics project. Now robotics have little to do with what IO does, but it also we also encourage them. So there was a video. So I'm just going to short info about what this video was about. So we were about to visit this APJ Abdul Kalam lab. And since this is rural, there is load shedding and the electricity is a very common thing. And the morning on which we were going to reach, there was no light. The students devised this thing that they had noticed that whenever they moved the robot or rover, they noticed that the motor rotates on its own. So what they did was they rotated a motor. They converted a motor into a dynamo and then they powered the whole system. So this was something which they are not taught. They are not taught about electromagnetic motors, everything, nothing. This is something that they noticed, something through their eyes, and they implemented it when it was necessary. Also, we have online basic Python workshop. So we have given Python workshop so that the students get, so as I told you that we provide them learning opportunities. So something like Python workshop, so that these skills can be implemented in LIGO collaboration, as well as they can use this in their careers, further careers. Also, we have this LIGO Livingston virtual tour in Marathi. So this was a virtual tour of the Livingston Laboratory in United States, and this had different experiments and also about the Livingston LIGO Livingston project. So there are 4 videos. You can visit us on YouTube. Then we host teachers training workshop, which is based on. So we had till now 3 teachers training workshop, 2 of which was after I joined. So we also had created a teachers training workshop based on the secondary school Maharashtra State Board curriculum. So over here you can see, and we also had created a book which was later translated into Marathi. So many of the Cyclops people and LIGO India IPO had contributed for this book. And so this book also had topics like LIGO India, gravitational waves, mirrors, lenses, lasers, which are already taught to them in the school level. Starfest events. So there was this Starfest event which was last year in Jan 2025. So there were lectures on general astronomy and basics of LIGO, setting up. We had created. So what we did was we got some funds from Newton Baba funds. So this is an Indo-Anglo fundraising company, I would say. But they had supported LIGO India in the past. And then, so we had created 5 LIGO India, 5 Khagol Manch, which are like Taluka Khagol Manch. There are 5 Talukas in Hingoli and 5 Khagol Manch we had set up. Each Khagol Manch had received one 5-inch Newtonian telescope and 2 refractors, small refractor telescope, along with the Listening to the Universe book, which was translated into Marathi and distributed. Also, this book, if you notice, this LIGO India Science Guidebook was also distributed to all the teachers over there. And there were workshops on handling telescopes so that we generate interest in for them in general astronomy. And this is the result of our Hingoli outreach. So now, after the we receive continuous updates from the Khagol Manch that we have created. They have big stargazing events around the year, and they keep sending us photos. Okay, the second part of it is to make engineers of LIGO India and scientists. So we do this also in different ways. So first is we split it into 2 parts. This is online and national outreach. I'll be talking about online outreach. So first, as I said, it's necessary to encourage women to participate in STEM and promote them. So we host this blogs, interview blogs. So basically in these interviews, we ask women scientists who are working in GW what their career path was like and how did they get into GW. We expect that this inspires other women who are reading our blogs to get inspired and join LIGO collaboration. Then we host podcasts, interviews and lectures so that the students can study from YouTube videos. This was done during the COVID-19 phase. We had also advertised all the opportunities on our social media platforms. We also communicate LIGO information. So basically, if there's any discovery happening in the collaboration, we communicate it through our social media handles and YouTube and other media. For example, this video of the cat, if you can see, this was specially made so that the people can understand, the common person who is scrolling internet will also understand what exactly has happened in the collaboration. We make it really friendly, a cat explaining the gravitational waves, what we have discovered, something like that, so that everyone feels included into the project. Now I will be talking about national outreach. So we participate at national level science festivals around science and technological festivals. We talk about the gravitational wave science and technological part. So the engineers, if there are engineers from institutes who wish to contribute or do some project under the collaboration, then they can also visit, they can email us and contact us. Also in this, then we also organize national level events. National level events such as, so there was one national level event that we had organized. It was a builder detector workshop. This was an online event which was in collaboration with the University of Glasgow. And so this was in collaboration, and LIGO India EPO activities, every EPO activity, let's say even about the scientific achievements that the collaboration has been covered by the leading national newspapers such as Times of India and Indian Express. Now the third and the last part is I want to become an astronaut. That's how from where we start the journey of astrophysics. But before that, I also wanted to become an astronaut, and then we get into the field of astronomy. So to encourage the young kids, we host different events such as this is an GW Sci Art event, which had different themes. So there are different art forms. There are digital art forms that we accept. We even accept hand drawings, paintings, poetry, and a lot of things. We have also hosted 2 astrophotography webinars, and one of them is active right now for Children's Day special. So that the children get included every small. So we also host guess what, quiz competitions. Did you know? We also talk about some online games which are available for them so that they can talk about it. And yeah, so thank you. So just I want to add that this astrophotography contest is still live. If you want to upload your astrophotographs, so apply. It's till 31st of Jan, and you can check out the LIGO India link to you. This is a new magazine that we have launched.
Thank you so much, Saurabh. We'll also have talks later in the evening related to, short talks related to mega projects, so do attend that. It's at 5:30. Thank you, Saurabh. You took up all your time, so I'll have to move to the next speaker. I'm really sorry. Next speaker would be Vikrant, I think. Yeah, you're here.
You can answer one question that will be studied.
Yeah.
Yes.
So I have a question that for your whatever outreach you have done, do you have any focused outreach on gravitational astronomy? This promises for high school teachers and students?
Yes. High school, you mean 11, 12?
Yeah, 11, 12, basic introductory.
Yes, we do
the
have.
promises of gravitational astronomy.
Yeah, so we give them an introduction because they now have an understanding of what interference pattern is like, and they know about now gravity. Now they can be a little bit introduced to gravitational waves. That would be easier. Yes. You can have a chat.
Okay. Am I audible to everyone? Alright, thanks. So, hi, my name is Vikrant, and I come from the Indian Institute of Astrophysics, and I'm here to talk to you about the work we do at IA, and I'll just start off to make sure everyone's on the same page. The Indian Institute of Astrophysics is a research institution under DST, Government of India, and our history goes back to the 1780s as the Madras Observatory, and currently our headquarters is in Bangalore. And we run 5 different observatories across the country. And in 2021, a dedicated outreach section called SCOPE, which stands for Science Communication, Public Outreach and Education section, was started, and it was built on the work that was done by the outreach committees before. This is our team right now, but there's actually a lot more that I didn't mention. We have about 30 to 50 people once we include all the representatives from different observatories. Right, so moving on. So this is what I'm going to primarily talk about, which is the multi-channel framework that we have for engagement with different crowds. The first one is, of course, the standard public engagement that everybody does, and one of the major parts of this is the 100 Bhaskara, which Roji talked about today morning, and the other one is an upcoming session about the Cosmos Mysore project that IA is running. It's a planetarium that we're building in Mysore. So please do catch that session. It's 13C happening tomorrow. The next I want to talk about is the astronomy education programs that we do for high school students and teachers alike. And finally, I'll conclude with large-scale programs that we conduct and what we've learned out of it. So let's start off with the astronomy education programs. I talked about this in the ASI conference 2 years ago, so I'll just quickly run through this. We run the Research Experience for School Students, or RES, program for high school kids. And we've done 2 editions of this, which is basically aimed towards all of those students who are coming from 10th to 12th standard. And this is a project which is unique because we sort of try to see that the students use very minimal plotting software and computers to do their research projects. And at the end of it, they present their work amongst to their peers and other faculty members at IA. And so far, over the 2 editions, we've had 32 students so far, and we'll continue to do this. The other program we have is the job shadowing program, where the student spends a day with supervisor at IA, which could be a scientist, professor, engineer, postdocs, or PhD students, which sort of helps them relate a lot more to the field. And since 2023, we've had again more than 30 students do this, and these are just some glimpses of it. As you can see, these are the instruments and the work that they've already done, and they do a lot of hands-on activities and so on. And these are the job shadowing students who've shadowed supervisors for a couple of days. Now, the impact of this is that the students initially were not really happy when we tell them you cannot use computers, because even in their schools they do. But at the end of their projects, they're like, oh, this is actually very interesting, and when they get their results, they plot their graphs and so on, they're very happy about it. Right? And this is one of the few research programs oriented for school students, and it is now one of the most sought after one. We've seen an increased demand in such programs. So that's not something we've learned out of it. The students have also found a new appreciation for the rigor that exists in the scientific method. They thought doing research is just reading papers or doing fancy plotting, but when they actually get into it, they started appreciating it a lot more. And our aim is to make this a yearly program where we do it in the summer break, so that the school students also are free enough to attend these programs. I'll now move on to the large scale programs. One of them is of course the National Science Day. It is one of our biggest events that we do at IA and all our observatories combined. Over the last 3 years, our average count has been a footfall of about 5,000 people. And every year we have about 30 plus attractions, and it is not possible with just a few people, so we have a volunteer team of more than 150, which includes everybody in IA, all the housekeeping, security, faculty, students, every single person, right? And they're the ones who make this possible. The public events that we do, I've just mentioned 2 of them. We do a lot more in this, but the most famous ones are Zero Shadow Day and the Asteroid Day programs, where we have some hands-on activities for the students to measure the lengths of shadows or create impact craters using stones and flour mix. So and every time we get like about 200 people attending these programs. We've also organized, as the IA Scope section and IA in general, we've organized 2 conferences so far. One of them was in the pandemic era, and it saw more than 150 online participants, and it was meant to facilitate or bring together astronomers despite the COVID-19 hindrance. And the other one was a bit more recent in March 2024, where we organized a conference on astro-tourism and astro-entrepreneurship, which I'm sure most of you have also attended either offline or online. And for that as well, we had about 120, 130 participants in total. Right? And of course, we're also very happy to be a co-organizer of this symposium, and I'm sure we'll get to learn a lot more about that. Now, this is a little bit of a spoiler alert because we have other sessions planned on this, so I'm going to keep this very, very brief. We have external collaborations with government and non-government organizations, and as part of our collaboration with the Rural Development and Panchayat Raj Department of the Government of Karnataka, we've been running this campaign on the Zero Shadow Day thing, and we have a talk by Yashaswini in the session 13A, which is tomorrow, so please do attend that to learn a lot more about our collaboration with RDPR. And an extension of that, and combined with other things, is the Total Lunar Eclipse campaign that we were running just a couple of months ago. And this again is a talk by Prasanna in session 9-8, so that's today, right after this session. And they will be, I think, either here or in the Chandrasekhar. So please do attend these talks to learn a lot more about that. One thing I'd like to quickly mention is that the live stream of this was carried internationally. BBC, etc. had carried it, and that was one of our great successes. And these are just some glimpses again. I won't talk about this, but this is from the ZSD campaign that we've done, and these were the places that have done this. And similarly for Total Lunar Eclipse, I'd just like to draw your attention to these 2. These were letters written by the students of the rural areas to us, expressing how happy they were to see the eclipse and what challenges they faced and how they overcame those and enjoyed the eclipse, which is a rare phenomenon. We've done also teacher training workshops. We've trained 300 teachers so far, and that's again with at our observatories with other organizations and so on. Of which I'd like to talk about just one of them, which is with the Karnataka Department of Science and Technology called KSEPS, who recently purchased 833 telescopes for the residential school network all across Karnataka. And that's a huge step. No other government has done that so far. And IAA is then collaborating with the Jawaharlal Nehru Planetarium to train all the teachers of these residential schools, all 833 of them, to learn what their telescope is about, how to use it, how to maintain it, and some basics about astronomy and the night sky. And of the 833, we've already trained about 500 of them. We have a couple more workshops scheduled right after this symposium, and that will go on for a while. A lot of work has also been happening at the observatory, so I'm presenting this on their behalf. The Kodaikanal Solar Observatory has a museum which hosts items that date back to the 1800s and gets like 50,000 visitors on an average every year. The Vanuatu Observatory again gets a lot of visitors, and they have an open Saturday every week, and they get like hundreds of people for those. The Indian Astronomical Observatory that Roger already mentioned in the morning in Hanle also gets tens of thousands of visitors, and their dark skies, of course, are one of the most unique things. And the engineering students are more interested in visiting our Gorabino Radio Observatory, which is run in collab with RRI, and our Crest campus, which is our technology center where we build our space payload. So the engineering students are a bit more interested to visit those places. We've also been running a multimedia campaign over the last 3 years now, since June 23, called #Skyscope. Where these are basically infographics but also serve as mythbusters to events that are happening around. That includes your planet parade or something very interesting about the 3i Atlas and so on. We've made about 54 of them. This is just a few of them. We've made about 54 skyscopes so far, which averages to like 2 per month roughly. And you might have seen these posts around. We also have been doing a lot of multilingual outreach, because at IA what works the best for us is the fact that we have students and faculty members from across the country who speak different languages. So that really works out for us. So we've been able to make many infographic videos and posters in various languages. We've been running the Axel series, which is astronomy talk series in Indian languages. We've done it in about 9 or 10 languages so far. And of course, the public talks that we organize during open day or otherwise also tend to be English, Kannada, Hindi, and so on. Now, I'm towards the end of my slides, so I'll quickly talk about the impact we've had, the challenges we face, and what our future plans are. So far, SCOPE was initiated in 2021. So since then, roughly counting, we've had about more than 250,000 people visiting all our campuses, includes students, general public. The number is actually quite higher than that, and more than 800 schools and colleges have interacted with us, either them visiting us or us visiting them, all of that. And we've conducted more than 250 public events across all our observatories and the headquarters. More qualitatively, we've had a significant impact or significant reach in the rural communities thanks to our collaboration with the RTPR Government of Karnataka and the Cosmos Mysore project. And promotion of dark skies, of course, has been happening with the Hane Dark Sky Reserve, but the Kablu skies, the Vanuatu observatory skies, and the Kodai skies have also been really, really nice. And we've seen an increased demand in the multimedia content. They wanted actual content and something that is more authentic and something that they can relate to, where multilingual aspects do come into existence. And so we're doing this, keeping our observatories as centers so that we can reach out further into those regions. Now, this slide I'd like to spend a little more time about the strengths and challenges that we have. The first one, of course, is that we're supported by the Indian Institute of Astrophysics, so that's really good for us. But we do have an issue of scaling, because there's just a small staff that works full-time, so scaling issues always are there. The next one is that we do have this multi-channel approach that I've been talking about, but reaching all demographics is challenging because we can only spread to certain areas. We have logistics issues, travel issues, funding issues, etc., etc. So we do have a problem reaching all demographics, where collaborations in that case, tend to help us a little bit. We've been doing multilingual outreach, so cultural sensitivity is taken into account. But so the result of that is difficult to create. So it's difficult to make a unified framework to measure the outcomes of all of it, because each region has its own thing. So it's kind of challenging to get an outcome from all of them in a similar manner. And finally, long-term programs create sustained impact, and this is something all of us agree with. But what we also agree with is that sustaining long-term programs is equally difficult. And that also includes all of those strengths that we have and the challenges that we have. Right? So the future for us, of course, the first is expand our programs to reach out to more students, We want to start working with other governments, state governments. We've been in conversation with a few of them, so we'll be extending our government outreach stuff, our government collaborations. And then we want to also train more people from the low income and the rural areas so that they can then become astronomy facilitators and train their students and keep that going. And finally, of course, we want to scale the outreach that we do around our observatories. A lot of it already has been happening, but we would like to reach a lot further into it. So I'll conclude saying IAA is committed to making astronomy accessible to every corner of India, in every language, in every community, through every possible channel. Thank you.
Ask the speaker to please put on his slide, which is here actually. So it's amazing that there's so much potential in our research institutes. We just need to take the initiative and support these activities. And you can see, I mean, I'm not taking, please not take it wrong, but if this was being done about 6-7 years ago, only IUCA would have been presenting. But now there's so many others presenting, and the activities that the ASI POC has been developing, they have now reached so many places. They are very relatively easy to do and cost effective. There are also best practices being shared. I think many students can take this up who have not yet gone that way. Thank you. Cheers.
Good afternoon. I'm Professor Sudha from College, Ratnagiri, Assistant Professor in Physics. So, this is a story of our astronomy club. So, not a great effort or that kind of thing. But from local outreach to national recognition, how we proceeded in 2 decades, that I have to here. There was no intention that we are running astronomy club and at some point of time you have to present something like that. So that was not in mind. We are just going to work tirelessly. So we are belonging to the land of Alfonso Mango and beautiful scenery. So we are keeping telescope under coconut tree, and we have nice fish thali, which is famous. So this paper represents a case study of this multi-decade effort in Bhopal region. So this is our college. So our infrastructure is very good, and all our principals and authorities they helped us to develop our astronomy club. So we call it as a Khagol Abhyas Kendra, and it is situated here. This is our habitat 17 degree north, and this is a very large ground. So for public events, we can have this. We use this ground for many programs. So our line is the line of scholars. You might know these names: Shankar Balakrishna Dikshit or S.B. Dikshit, who has written a very nice classic book on astronomy. Then Lokmanya Tilak, who was born in Ratnagiri, his birthplace. He has done many work in astronomy as well as in politics. And Venkatesh Bapuji Ketkar was belonging basically from Ratnagiri, near Chipur. Then there was the first in Marathi, which is called as Akashatil Dekhawe, means sky charts. So first book with sky charts, but it is out of print and is written by a headmaster of a school. So it is, I think, 110 years back, it was written in Marathi. And then this is a teacher for all the generations, Professor Mohana. Apte, and he was a demonstrator in our college when he started his career, and he has contributed too much in Maharashtra, development of astronomy in Maharashtra. Then our story begins in 2005 when we met with JVN at Goa symposium, like that astronomers meet, and there we started from day one. Our primary aim is to communicate astronomy in Marathi. All our materials, lectures, workshops we are taking, all the material developed in Marathi, because Marathi as a language has a lot of treasure of literature in around twinkling stars, dawns and nights and poems, all the things. In Marathi language, we are using as a public outreach language. We are doing everything in Marathi, and we conduct school workshop for teachers, telescope handling for students, daytime astronomy activities, teachers training, and some small certificate course from our institution or from our Khagol Abhyas Kendra. And these activities are conducted every year as our astronomy season starts, like this symposium. So this is the historical visit of JVN, and we had 6-inch telescope and few books. But he encouraged us by giving some talk, public talk at our place, and he has given and written best, we can say, Ashirwad to us that we should keep our feet on ground and see the sky. So this is my best wishes to the center. He communicated on the occasion of the International Year of Astronomy. In 2009, he came there. He was 8 days there at Ratnagiri, both Professor Narikar and Mangala Narikar. Then we slowly associated with other institutions nearby, Friends of Astronomy of Goa, because Goa is 200 kilometers away from us. And we connected with them and few lectures with Goa people. Then Pune is also contributing in astronomy too much, and we have one big program with us with Pune. So we students contributed from every school, and we donated 3 telescopes in our town. So 3 schools equipped with telescope, and some teachers also trained at that time. Then we visited with Professor Mohan Apte, that annular solar eclipse at Kerala. That was one motivating thing for us. So the student at that time, she is working now in aviation industry, and she is one of the inspiration for us also. Then we conduct local scientific programs as astronomy activities. We started with 3-inch telescope. Now we have 6-inch Osbornian and other telescope. We took every occasion of communicating astronomy to the students, like Inspire camps and other some occasions we get the opportunity. And nowadays we are conducting some large programs with the international schools. Nowadays we have Ratnagiri is also growing, so we have also opportunity we are getting to communicate astronomy by means of sky gazing programs or lectures and talks. So this was a solar lunar eclipse, that was a huge program we conducted. And local schools we organized for kids sky gazing programs and other astronomy activities. So this is in the college classes. Every year we celebrate Science Day as well as the Zero Shadow Day activity, and that was we get wide publicity for these occasions in local newspapers. So this is one of the features, and students are preparing well ahead to celebrate Zero Shadow Day at our place. Then we tap every sector of education from primary school to college students. So annual days, people invite us to, along with their annual programs, there is one part now, default program of astronomy club at any annual event of nearby schools. Then secondary schools, we are giving some popular lectures depending on opinions, and promote daytime astronomy. They started some astronomy clubs or Khabur Mandalas in 2 schools in our city, and at the weekends or after 15 days or 2 weeks later, we conduct some hands-on activities for students. Also, astronomy art, we conducted 2 such big competitions of astronomy art, color grading and poster making. We have got huge response for these activities. Then higher secondary, we conduct basic astronomy workshop for 3 or 4 hours, and after that, sky gazing program is there. So every sector of education we are trying to tap to promote astronomy. And this is the picture of a school. So we are expanding our network by giving information ahead of on such occasions. So it is 60 kilometers from Ratnagiri, and that school is also working under our guidance and doing astronomical activities. This is another school which is nearby, nearly 30 kilometers away. This is Kadwai school, which is 40 kilometers away. So they are also in daytime astronomical activities. Then local home schools are there, 2-3 local home schools are there. So we also train their students, and we encourage them to buy a telescope and do some such type of small programs. So this is 2 of our students. I can proudly say that after getting the inspiration, one of our students done in IISc. So he was a motivated student from our astronomy club. And Padmanabh Sarvota done MSc in astrophysics from Mumbai University, and he is now assistant professor at Bhaskara College in Ratnagiri district. Then we have occasionally we promote by some radio talks and some popular lectures like Professor Bhaskara from IISc Pune, then Sarno from Asimi Pune, and a lot of their Professor Mr. Datul Soman was also frequently came to Ratnagiri to deliver his popular lectures. Then as we developed, also we had opportunity to connect with the local planetarium, which was established 3 years back, and now we are the resource person there. So people, municipal corporation call us or our students to brief some occasional programs to VIPs or the trips which are coming. So this facility we are using, and under ADP, students are getting benefit for their community engagement program work, and they get 2 credits for their academic certificate, or that will be started next year. But already the students have started working with this planetarium. So the planetarium has a beautiful astronomy gallery there, where we interact the trips are coming from nearby districts. So it is now popular. Ratnagiri Planetarium is popular in Maharashtra. Then the VIPs which are coming, visiting occasionally, so we are briefing them, and municipal corporation asks us to visit at that time. So these are some occasions. Professor Mashet also visited our planetarium. So a small astronomy club from our college, now we have connected with this local facility, and using that we are associated with this planetarium, and now we are doing some programs with the planetarium, like celebrating anniversary of planetarium. Then as I told that we under LGP we offered open elective course for arts students, basic astronomy course for arts students, and these students, as a practical work, they communicate astronomy in this facility, so in this facility. So as a result of all these activities, we got opportunity to take a state level conference of amateur astronomers, and social media helped that. So I have So it was in 2023 with state level goal Abhyas that was done and that was the first in open region. So we connected with the state level network. So these people are there, visited our Ratnagiri Taragar. This is the group at that time we have. These are our eminent speakers. Raviji Bole, who is demonstrating there also with models, Professor Bharat Adu, and this is Anand Kaisa from Mumbai, Bhava Center is there, and Datu Soman, Hemant Mone, and we have our coordinator here, Sarveji. So we were there also for this. So we are getting such encouragement from connecting our network with other people. So this was a great occasion for us. So we have therefore the connection with NCI, ISA, Pune and Ayuga. Then on the occasion of Chandrayaan, we developed such a models and one corner that opportunity we received to promote Chandrayaan 3 as well as space science and astronomy. So as a result of these two major efforts, now we applied on ISRO website and they allowed us to become a registered space tutor. So we are working in that direction, and due to such kind of symposium, we are now getting the direction how to proceed further. Because it was not the work done for some paper to present here, but this 20 years effort. And now next we are going to recently conducted this astronomy tourism program. So this was, I was talking with him, so he suggested few things, and recently we conducted one certificate course on basic astronomy and how to show the sky to the local people. So another faculty from IFA visited at time. We conducted that with the help of MTDC and Pradhan Mantri Ujjwala Yojana, which was funded by that. So our goal is to have some employment opportunity or rozgar for our graduates when they come through the astronomy club and learn and communicate astronomy to society. Thank you very much.
Thank you so much. Moving to the next session, I don't have the slides for them. The speakers have their slides here. We are very thankful if you. Okay, perfect. Thank you. Yeah, I should not finish without appreciating the work Bhaskara is doing in this college. And I think the courses are very nice, so we should publicize them more. It's a very good idea. And if anybody is interested in giving a talk in his place, you can get at Mangoes. And his Google location didn't show the next door beach there, which is also lovely. So that concludes the institutional outreach session. So the next session is about using digital tools and AI for communicating astronomy. You've been seeing the beautification that has happened in all the slides. So it's already started. I can see very basic levels to start with, but then there are many advanced things which are happening. I'll be chairing this session instead of Mumtaz Syed, and I welcome the first presenter, Athura Pathak, from Ayuka Knowledge Cluster, to present. Thanks.
Hello. Am I audible like that? Is the audio okay? I will for time. So, good morning everyone. It is nice to meet you all again and talk to you again. So, today I am representing the Pune Knowledge Cluster, which is a section 8 company hosted by Ayuka. It was set up by the Office of Principal Scientific Advisor to the Government of India. So, we report to the PSA office, and there is a mandate that we work on these focus areas. So, I work with the big data and AI vertical of the Pune Knowledge Cluster, and what we have done under that is we have developed a project called 1 million galaxies. So the acronym is OMG, it is 1 million galaxies. The intention behind designing this project is we want to create AI-based or ML-based classifier which will help classify large volume data sets of galaxies based on their morphology, meaning based on their structure. So whether a galaxy is a spiral, it is a bar galaxy, it is a bar spiral galaxy, it is a ring galaxy. So we have identified 8 such features which help us catalog or classify those galaxies with a significant confidence, meaning with a good accuracy. And we want to create this catalog as a ready catalog for larger surveys that are eventually going to start feeding a lot of data. So in astronomy, just like the cosmos and the universe, the data sets are also astronomical. You might have heard or you might have read that all the upcoming mega science projects are going to generate terabytes and terabytes of data every single day. So the upcoming Rubin observatory or the Roman observatory or the Euclid observatory are going to generate terabytes and terabytes of data in a single day. So far the SDSS catalog had in the data release 7, until data release 7, had created about 600 terabytes of data. For Rubin observatory, it is going to generate 100 terabytes of data in a single night. So imagine the scale at which we are increasing the data and increasing the alerts with the multifolds. So human beings cannot do these classifications and analysis manually. You will have to take help of the intelligent machine learning and AI-based algorithms, and also the new modern tools that develop with it. Now, we will quickly run through these slides. This presentation is generic. It is designed for people who may not have any background in astronomy. You all are aware that there are all sorts of galaxies. So, Edwin Hubble had created this Hubble classification or the tuning fork diagram, where he had classified galaxies based on their structures. So the left part of the tuning fork shows the elliptical galaxies, and then there are spirals, and then there are bars. So these are the different identifiers that are used for classifying the galaxies based on their shapes and morphology. So these are some of the sample data images that have been consolidated to show you different kinds of galaxies. So these are some lenticular galaxies. These are some examples of ring galaxies. So there are different kinds of rings that you see in galaxy images. Now, these are some examples of interacting galaxies, where there are also some dust lane features, which are some very interesting features that we see. We also see tidal tails. We see bridges. During these features are often seen when the galaxies are merging or have merged and are in the process of separating. So all these interesting features can indeed be identified by simple observation. You don't need to be an astronomer, or you don't need a lot of training to learn what the features look like. And if you see a subsequent galaxy of a similar looking type, you can very well classify or label it. So that is the whole project. So we are using the help of citizens to help identify the features that they see in a galaxy image, and based on this input and a certain number of responses per galaxy, we use this information to train a machine learning model using what is known as supervised learning, because there is an image and that image has a label, and based on this learning, the machine learning model then understands what a spiral looks like, or what a bar galaxy looks like, and whenever it sees a new image from an unknown or unseen data set, the machine learning model will be able to classify the galaxies by itself. So this is an example of this is the image of the Hubble deep field. So apart from the bright objects which have spikes, each and every dot that you see in this image is actually a galaxy. Now we are in the realm of James Webb Space Telescope, and we are building even bigger large-scale observatories, and we are going to look farther and deeper into the sky, and we are going to see many, many more galaxies. So currently the astronomers estimate that there are about 2 trillion galaxies in our universe, right? And although we may not be able to see all of them, but we are going to see too many of them. And in order to understand their physics, in order to understand their morphology, in order to understand how galaxies evolve, and how their population is distributed. It helps classifying or cataloging them. And you need, as an astronomer, you need a reliable catalog on which you can do different kinds of research and different kinds of tests. So these are some of the common telescopes, multi-wavelength channels, which produce large volumes of data. So right now, these are some more examples that we typically show when we want to talk about multi-wavelength astronomy and how one can use these catalogs to correlate and understand physics using the multi-wavelength data as well. So we have used the data from the Subaru telescope. So this Subaru telescope is run by the National Astronomical Observatory of Japan. It sits atop of a volcano in Hawaii, in Mauna Kea. So this is a 8.2 meter diameter optical telescope. It also works in infrared, and it sits at the summit of Mauna Kea. It has a camera which is called the Hyper Supreme camera. So it is a very high resolution camera which produces good quality high resolution galaxy images. We generate cutouts of those images and show those cutouts to citizens. So in this process, many times citizens who are part of all walks of life, or they could be project students or interns in a school or an institute, or they could be simply science enthusiasts like all of us, can easily participate in such a project. So these are some of our knowledge partners. So this project was developed by Professor Ajit Kembali and Sudhanshu Barve from Indian Institute of Astrophysics. And this project has been developed by me and a couple of my friends who have developed a website and a platform. We also work on the data analysis part. And we hope that the classification, so far we have classified about 392,000, we have had about 392,000 classifications, but our ultimate goal is to classify 1 million galaxies and eventually catalog. So we have some publicity partners which include planetaria and local astronomy clubs, with whom we try out different variations in the user interface. We also try out different variations in the analysis techniques. If you want to get certain number of galaxies analyzed in bulk with certain changes, we ask these active volunteers to work on the data in a short duration. So this is a timeline. We started this project in the we opened this project on the Science Day of February 2022 in Ayuka, in Chandrasekhar Auditorium. Since then, there have been 392,000 plus classifications done by about 2,200 people of multiple galaxies. So the format is we either do roadshows or we visit institutes or schools in person or colleges in person and train them how to use this platform. Alternatively, there are already online resources. So if you go to the website, there exists a resource page where you can follow a screen sharing based tutorial of how to use the platform. But before that, we have also added some videos which have been delivered by Professor Kimbali and Professor Barve to talk about why study galaxies in the first place, what new information can we learn if you have access to a good quality catalog, and what kind of physics can be studied if you have a good quality catalog. So it also tells you about what scientists do with your classified data. So this is the interface. So there are reference images. So if you click on any of the reference image, a pop-up appears and the image gets enlarged. You can see it in a very, very high resolution. So these cutouts are generated using the Sloan Digital Sky Survey, which uses the Subaru telescope data. And if at all there are multiple galaxies in an image, what we expect a user to do is only classify or only label the image that is at the center of the frame. Let's say there is an image here and then there is a better looking or a more beautiful spiral over here. We expect the user to classify only the galaxy which is at the center of the frame. It is to avoid any confusion and misclassification. So one thing that we have done differently from Zooniverse Galaxy Zoo or Galaxy Cruise project is, apart from asking users to classify what features they do see, we also have given a provision to users to classify the features that they don't see. So because of that, what happens is your model learns faster and it also avoids any confusion. So if you want to teach the machine learning model that this is an edge-on galaxy at the same time you can teach the model that while this is an edge-on galaxy, it is definitely not an elliptical galaxy or a spiral galaxy or a ring galaxy. So this information is then used by the model for learning. So this is something different that we do. Based on this, we have also done some statistical analysis which tells us how many minimum number of responses do you need per feature to agree that the feature indeed does exist in a galaxy. So we have used these yeses and nos for doing that statistical analysis. So this is a typical format. People like using 1 million galaxies project because they are also able to download the participation certificate. And another motivation to keep classifying more galaxies is it also shows you how many galaxies have you seen. And many a times the coolest feature about such platforms is, so this is just the backend if you are interested in learning what we have developed it using. It's a simple Python Django based website hosted in Ayuka. So it is very lightweight, it can run on all devices. So these are the typical distributions of our citizens. So we have students which comprise of 70%. We have homemakers. We also have a lot of female participants. So we have about 40%, which is 632 female participants. So this is old data. I should have updated this. So there are lot many more people now. So it's now after adding more citizens, it's nearly 50-50. We have working professionals who have entered their different professions and they are also actively participating in this project. So this is the distribution of participation from different states and we also have international participation. So this is the distribution of features which matches the natural distribution that we see in the sky surveys. So this is a result of random selection of images that we show to the people. And right now this is, we see lot many more spiral classifications compared to the rest of the features that are mentioned here. So these are some of the statistics that I was talking about. Particularly for spiral, we have observed that if a galaxy has been looked at by between 30 to 50 people, and if they all agree that there exists a spiral feature in a particular image, we indeed can say with more than 95% accuracy that the galaxy that they have marked spiral is indeed a spiral. So it reduces your time for showing the same galaxy image to a certain number of people and helps you show more number of galaxies to the people to have more classifications there. So these are some of the students. We have a student from Bangladesh and also from Kerala. So we have many more students from right from Kashmir to all the way to Sri Lanka and even abroad. So my presentation here is done. I just want to end with a quick story. So the reason why we run this process, have you heard heard about this object before called Fure? So I'll just quickly tell you in 1 minute that this Fure is basically Dutch word for object or a thingy that we say in English. So this lady is a English teacher in a Dutch school. So just like 1 million galaxies, she was classifying these galaxies in a citizen science project of Zuriverse called Galaxy Zoo, and she found this greenish frog-like looking thing below the galaxy, and she reported it. So she was vigilantly very properly entering all the classifications, and after her reporting, somebody in the team got a flag that okay, there is some reporting on an image, there is some unlisted feature that was seen, and all these questions came up. Is this object real? Is there anything else like it? Is it local? Is it a sensor artifact? Is it a defect? And after looking at the older images of the catalog, they indeed did find that object. Then they took another image, which was a recent image, and they saw this object again. And after a little bit of research, they found out that this object is a whole new class of object that we had never classified before, we had never seen before. And that is basically a result of a galaxy ionization echo. So a very long time ago, a nearby galaxy passed besides IC2497, which activated the quasar at the center of the galaxy, and it started throwing these polar jets, which ionize the gas around the galaxy. Now currently, the quasar is not active anymore. The nucleus of the galaxy is not active anymore. However, this ionized gas is still emitting. and you can see this gas as an ionization echo of that active galactic nuclei. So it does have a lot of interesting opportunities. Citizen science projects as simple as that can help a totally layperson or an untrained astronomer to discover a whole new class of astrophysics objects. So it is very exciting, and the best part is you get to see images from a 8.2 meter diameter telescope that probably nobody has ever seen before. So it gives you great open access to looking at state-of-the-art data, and then astronomers discovered more such objects, and then there is this whole new class of objects. So with that, I would like to end. So if you have any questions, we can also take them later on. In the interest of time, you all can catch up with me outside. So I'll be very happy to talk to all of you, and I would love all of you to participate in this project. So this is the QR code and more information about us.
I'll ask Masood to come up. As Athro said, he's also a very active volunteer in this conference. So is Saurabh here, and you can catch them at other places. They'll be hanging out. Thank you, Athro.
Hello. Am I audible?
Yeah.
Yeah. So first of all, thank you SCA and ASI for inviting us to present our work. So today I will be talking about our institute's digital initiatives. And before that, I would like to present a quote which is very close to my heart, that is ad aspera per aspera. If you are a Star Trek fan, you might be knowing this. And since 2 days, I am seeing that a lot of science communicators are doing really hard work to, communicating astronomy to the very end of India. And I really appreciate, and I'm thankful for the organization committee to give us an opportunity. So first of all, this is our institute. It is located in the heart of Ahmedabad near Gujarat University. And the unique thing about this science center is that it is free for all. And we have a motto, question, explore, discover, where we ask students, scientists, educationists, and everyone to participate and bring in a community-driven science approach. So I have a small video which will give us the length and breadth of our work. Just a 2-minute video. Quickly telling you about the institute. It was founded by Dr. Bhaskara in 1966, and our symbol represents that we interact with teachers, educationists, student, community, and scientists, and we are trying to bring a change. That is the delta sign in our logo. And some of the first which we have already seen in the slide. So this is the picture of Professor C.V. Raman, who had laid down the foundation stone of our institute. And past President Dr. APJ Abdul Kalam was chairman of our governing board. A few eminent scientists which are also like Professor K. Kasturiranjan, who was pioneer in NEP 2020 and was leading that also. Apart from that, we have also Professor A.R. Rao, who was a well-known scientist in mathematics field. And we have a focus area of STEM with astronomy and emerging technology included with that. And we are proud to say that we are ISRO registered space tutor in Gujarat. And these are the areas of intervention. Why we are talking about this? Because we think that these are the 4 pillars of education, and we also have been pioneer in setting up STEM labs. We have set up space labs in across Gujarat. We have also set up astronomy labs which have 5-inch reflector Newtonian telescopes with them. So we guide them to observe skies during their astronomy events. And we also been developing teacher learning materials since then. And no work is individual work. I would really thank this committee for accepting all 4 of our abstracts. Unfortunately, we 2 are present here. Mr. Zeel Patel is here. If you can raise hands, he will be having a poster P43 just outside this room where he is talking about how paper-based astronomy models can be made. And talking about the digital and AI in astronomy, we see that from 2018 we had set up various space labs with our CSR partners. These are like 90 plus right now. And after that, Khagolshala labs kind of things came up after just before COVID, and it is now gaining momentum. We also have a space week where people are students are trained for ML based classifications, and we have a government backed SOAR initiative which is having a national alignment in AI scaling up for various people. The recent contribution from India AI, which is a government initiative, also acknowledges the ISRO's achievement in AstroSat. Maybe that can be used for future digital AI thingy. And if we talk about the global shift, we have 100 terabyte multimodal universe dataset, which is currently present in Hugging Face repository. So if you have access to machine learning database, you can go to it and you can learn about the classification. And we have different regions which are currently giving a momentum to the global shift regarding the participation of people during digital setup. And if you talk about the ground realities on our Indian part, so we have to be reliant on mobile adoption. We also have constraint of high-speed data access, so internet is a little bit slower here, and the urban versus rural thing is there. So if we talk about India's urban and rural divide, we have a lot of phase which we can see here. We have pros and cons which are listed here. So we can see that there is a skill loss, which is a very prominent thing which comes up every now and then, that if digital and AI things comes up in future, then there can be a cognitive loss among students. But keeping that aside, the main challenge is that moving beyond science is that if we take help of digital and AI tools, it can be a real force multipliers. And the challenge is that how we can mandate NEP 2020 against the infrastructural details. So there is a saying that whenever there is a problem, there is an Indian solving that problem across the globe. So we are trying to do that, and for that we had run a pilot program, which is an urban computational astronomy cohort among 50 students in urban demographics. This is a little bit different from what we do in our institute. So this is like use of digital tools which are freely available and open source. So the input cost is very less. So the methodology is that we teach students in a 5-day cohort for 3 hours daily to understand the raw data which are in the FITS file. We also teach students that how to access those data from the servers and how to analyze data, especially from exoplanet perspective, which is available at TESS. And then the student learn in 3 days how to process those data and how to remove the unwanted noise or any delimitation from the data set. And then they start discovering their own stuff. So here there are a few examples that we have given them minor planets data which are for asteroids, and they have flagged some of that they are really potentially hazardous or not based on the analysis. On the
left-hand side, we have seen JWST. This is a public data set available in the JWST website. So students get these multi-wavelength data set from JWST website, which is publicly available, and they analyze it. And if we talk about some statistics, so these are the demographics among the students. So we see a higher girls participation in coding, and we believe that one of the students say that they want to do astronomy, but they don't want to go with the telescope and viewing, and they are more interested into computational stuff, applying logic and doing some grassroots level analysis. And here is the post-test and pre-test results. So we test students on Python skills, understanding of astronomical units, which we taught them during the class. In the theory section, we also learned about the orbital motion and the data input output, how to read a file in Python and Jupyter notebooks, especially Colab, how to mount drives and stuff. So we have seen that overall 39% increase is seen when they learn this kind of digital tools. And please remember, these are about urban kids who has very high niche in coding, because right from the 3rd or 4th standard they start learning block coding, they start learning Scratch, and that's why these numbers are very high. This could vary if we have a rural setting based on the amount of communication, and we also have the impact on understanding that they started to learn AstroPython, basically AstroML and AstroPy things, but as soon as we move to Jupyter, they find it very easy to learn coding, because every block you have to run, and there is this little bit lag sometimes, so they really are very patient with the data set. But when it comes about space telescopes, the graph is a little bit down, because a lot of websites which gives you space telescope data set needs a very intricate way to find out how to download those data sets. And when you talk about JWST, the file goes around 1 GB sometimes, so they have to be really patient with that, and that is the bottleneck of this thing. And we also give them 1.5 hour projects to complete, and in that we found that majority of the students will be able to complete completed their project, with few people needing really support in learning the logic of the program. And we have also analyzed the impact of astronomy learning, especially the computational thinking, digital literacy, analytical logic, and physical mastery. And we see that in all those things, the Python integrated learning is more compared to paper-based activity or hands-on experiential learning. And lastly, we also collected student surveys, and we find that majority of the students really appreciate in urban setting the initiative which we have brought, that digital analysis can be a future of astronomy education. But there are few failures, as we all know, that we cannot give them ready-made code, because that would make them, the word is very bad, I think code monkeys is not the appropriate word, but when we see them, when we give them ready-made codes, they are just trying to run everything without understanding. So the fix which we applied in our cohort is that we give them pseudocodes with some hints, and we teach them flowcharts, the logic behind the analysis, and then we tell them how to operate. And the urban code that we run, how it aligns with standard curriculum which is there in NEP 2020 and along with the global trends. So instead of having a massive data set, we can go for a human guided AI approach. So in future, what we can do, we can create a small ML code which can classify locally this data set. Once you have a repository, the whole repository can be downloaded and that can be run. And the leverage is that it requires very less of computational space. And why it works? Because the pedagogy is involved in this, so they learn coding skills, they learn astronomy knowledge, and the digital literacy is also there, so that they come to know how to read the files, and it gives you industry ready among the students. So this is the feedback work. I will skip it. And yeah, so this is my last slide. Thank you everyone, and this is a QR code. If you have time, please do visit us. Mr. Zeel Patel is here, so he will be presenting a poster on hands-on learning models which is created by us. Any questions? Thank you very much.
I have one question.
Okay, so there were 50 students. So we started this in 2023. There was one student at the first batch, and she was a girl. And she said that I want to learn astronomy, but not the astronomer skill. So we started this with that student, and that got a word of mouth publicity. And on the next year, 2024, we had 22 students, and the number increased in the later years. So this is still 2025. So every year the number keeps on increasing, and in urban setup, I see that there is a increase in demand that student wants to learn coding with some specific context, and I think this astronomy gives us that context to teach them digitally about this wonderful universe.
Is there an open call for students, like anyone can apply or something?
Oh, very good question. So we have a summer program which is dedicated astronomy boot camp. So this cohort is run only in summer camps when students are completely free from their education burden. So it's a 5-day cohort. Every day we have some theory as well as practical classes, and in that they learn different stages of data analysis and stuff. So we give them projects of asteroid mining, and another project which we teach them is about space data, space telescope data analysis. Any more questions?
Thank you. Running out of time, but of course, she is not there last time.
Thank you, Ayuka, and all the students for organizing this and giving us the opportunity. Hi, I am Akshat Singhal, and from HBCSE team. I am going to present the work we are doing regarding the astronomy conceptual series on YouTube. So our team is Aniket, Suresh, Sai, Yogesh. Some of you might have met those. Sai, Yogesh. Right. So, so based on our experiences with students and teachers, yeah, is it better? Okay. So, based on our experiences with the students, when we interact them, we go to the school for education, research, or for CAS purpose. The number one question that we get is, we are interested in astronomy, we teachers or students, where do we start from? What resources do we follow? What should be step-by-step guide? I'm very interested, but I have no clue, right? And typically, when like they do find across some resources for Olympiads, for competitive exams, for amateur astronomy, but these are very scattered resources, and not all of them are beginner friendly. And if you are just interest driven, then it's further more difficult to start with anything. And yeah, so how about some solution? One could be some sort of supplementary resource, some reference materials. But the problem with this is it's not very scalable. If you have to write some new chapters or and distribute it to kids, it will take a lot of time for it to reach, to refine and all, and especially to update. Teacher training camps, online session, that could be one method, but again, it requires a lot of resources and planning and thing. So online videos that we record, we posted on some platform. This is one of the few trade-off that we could come up with, and it's usually fun and short time, or at least we thought it takes short time, right? So next question was, what kind of YouTube video should we look for? So like there are stuff where there is some digital tool people use, there is a speaker at the corner, some slides, there are some classroom recordings, these are blackboard recordings, so there's plain slideshow where there is a voiceover or narration. We chose for a slightly more fun path. We had our slides made in Canva and more design friendly way. We focused a lot on visualization because that's one of the key struggling points people struggle with. Because we have some experience with Olympiad training, so we thought of covering those topics which typical curriculum or whatever curriculum we have in various places don't cover. Yeah, we were proud of showing a lot of in-house graphics, things that we have developed along the line. And with all these in mind, with some digital screen, we went ahead with that. So far we have like 53 videos in English, 3 in regional languages. Why only 3? Because we are limited by editor's time. If editor is not available, we don't get that many things. But again, we are looking for more modern solutions, AI based or whatever. You can, if you search for astronomy for beginners, you will find, or just go into this link. So these are some of the thumbnails again we came up with. Also, that was planned that way, that thumbnails and all the graphics must be eye-catching, must be interesting. No, so we planned some time for that as well. Yeah, and we purposefully went for the way where speaker is very largely available, like it's on screen, because gesture learning is also one of the key important things. So if we explain, okay, this is a conjunction and opposition to it, this happens. So that plays an important role. So we did not go for the corner one. So all these things were usefully noted. And again, you can see that for you are keen in the graphic manner. And for visualization, again, we made sure that if a concept is being explained, we choose the right graphics for it, we choose the right method to explain to it. There should be examples that typically are used in scientific conferences and all, or photographs that we ourselves we have taken through astrophotography sessions or other things. So, these images are not very much used in teaching. So, like this is just another example. So, people think magnification increase is a universally good thing, but for a same telescope diameter, it's not, and so on and so forth. Right. Again, there are some visualization that we made in-house. So, we are planning to create an entire world of astronomy where you can switch your camera and could be interactive. So this is how, although in celestial sphere things are considered constant distance, but actually they are 3D, and concept of constellation that Orion is a hunter breaks down when you actually look at the 3D things and all. So again, all these lectures were highly based on good animations and good conceptualization. So not only we used proper animations, but all the explanations and all. You can visit the YouTube videos and see for yourself and give us suggestions of what we can improve. But combination of gesture teaching, animation, visualization, in-house graphics, we plan to have all these concepts covered. Right. Then we also made sure that all the YouTube videos have some sort of problem solving, very short maybe, but not because in beginning if we give a lot of heavy problems, then it might student might lose interest. But enough for them to understand and carry it over to the maths way. So they all had some small problem solving techniques inbuilt into it. If we look at, so after once we have done, we asked a lot of teachers and students how they felt, what their common concern was. Most common complaint was the audio is bad because we were not recording in a studio in our own office space, so there was a lot of echo and all those things. But even with AI cleaning, it was not that good. One was we don't have enough videos, enough problem solving videos and all. Another very common complaint was we have a lot of videos. That we have covered so many videos on solar system. Why do you need so many videos? Just put a data sheet, Earth mass this much, radius this much, Moon mass this much, radius this much. Why do you need an entire video on this? That's so boring. So, but although we covered a lot of planetary science, we were not able to communicate that why these things are important. You just not have to memorize these numbers. People usually prefer those videos in which a complicated concept is break down in multiple stages, reductionist method, if you see. People do prefer subtitles and chapterization, and we have been engaging with the comments sections. People ask a lot of doubts, they criticize the praise of videos, and we do all those things. This is one example of breaking down. So NLMA was the one which got most of the comments from the Olympiad participants. So, for example, NLMA is something that you see if you observe sun, don't observe sun without proper protection, but if you observe the sun at every solar day interval, you will see this figure it made. And the reason for that is the sun has an inclination. I will not go into the detail, and so the mean sun and the projection of that on right section, that changes. It also depends on the eccentricity. So all these things were, told more in a getting way. But this is something, if a concept is broken down into smaller bite-sized things, it usually helps. And that's why we made sure all our videos are between 8 to 12. We try our best. Sometimes we go ahead on. So between 8 to 12 minutes of videos, and we cover small topics, and eventually we have covered all those things. Now, okay, we have made this videos. Now, as astronomers, it's important to have data, right? And YouTube provides us a lot of data regarding this. So we know, in fact, it's a common competition among ourselves whose video is winning and who has more views and all. So for now, Sai is winning so far. So like we have this stuff when which video has been uploaded, which has how many views, watch time and all. The most common trend is whenever the video is launched, we post on social media, on Instagram, hey, there is a new video, go check it out. At that time, there was a sharp increase. After that, people sort of settled down. Whenever there are exams, Olympiad exams, camp exams, there is a humongous spike. And immediately after the exam, humongous drop. Right? So yeah, things are there. Right now we are not boosting paid on social media. So these are organic. There is a tussle between us and our seniors. Should we pay taxpayers money for this or not? But anyway, we'll come up with this later. Another stat that is slightly worrisome is if you look at the gender distribution since first January 2023. 50% of our viewership is coming from girls viewers across all ages. This is worried because it was believed that women participation is less in astronomy because they don't choose on early stages the maths and science field or engineering based field, but YouTube is open for all and still we see this. However, for shorts like YouTube shorts or Instagram reels, there the distribution is inverted. There we see more female participation and all. If you see for past 28 days, again it's now exam times and all, is more highly skewed, which we want to change. If you see geography-based distribution, only 52% viewership comes from India and rest combined elsewhere. If people are looking from playlists, then they have higher average viewer, like how much time they spend on a video before they go in this. So which means people prefer if everything is under one roof, they have all the concepts at one place. If they have from suggestions, it's slightly better. But YouTube search and randomly coming across is not that much preferred. Recently we have decided that we will add some more animation. These are all in-house animations. So this is made using Python and a Blender software tool used for 3D animations. Like for example, the Doppler shift graphs, these are aligned exactly with the Kepler motion of two binary stuff. So it requires more Pythonized, more computerized things. And then Python, YouTube tells us that how much retention we have got as a function of time. So if you start with 100%, you go up to 46% in first 30 seconds, and this much, and so on and so forth. So this stats have improved when we have used more in-house animations. And this is a small stat, so we cannot conclusively say this. Right. Lastly, we are working on some series where we want to explain to students and teachers how exactly, historically at least, people have done astronomical surveys and understanding and concluded stuff. So something as simple as how do we know Earth is round? Okay, how do we know Earth rotates and not the other way around? How do we know Earth revolves around the sun and so on and so forth? So this is not something you can just look at the sky and say, aha, Earth must rotate. It requires series of long observation, careful recording and so on and so forth. And usually these things are not taught in any of the curriculum. But these are something that once we teach students, we have found that they have sudden rise in interest that, just from the naked observation and series of them, you can actually do this. So for that, we have, now again, all of these videos are, so over here you could see that based on the inclination of the Earth's axis, you see the terminator line for every solar day. So it's noon on English Standard Time. But you can see these things change. Similarly, if you look at this. So again, we have used computer programming to how parallax would have affected how we would have seen this. Because we don't see this in daily motion, it was wise for earlier astronomers to think Earth is stationary and the rest of the universe is maybe dome-like or whatever. So although in common conception we think behind geoscientific model was a poor model, but astronomically speaking, based on the observed data what they had, was a very clever model by then. Okay, but and how from observing from here we reach to a point where we can definitely say Earth is revolving around Sun and so on and so forth. So these require a series of short fundamental concepts that we need to implement, and that's what we are planning for. So yeah, a few more videos will be coming soon. This is our editorial and entire teams that we work with. We have some scientists and guest lecturers that we also included. And yes, that's all from our end. This is the QR code if you want to look at the playlist. And if anyone would like to collaborate or have suggestions or feedback or any translation English or whatever, we will be able to do that. Thank you. Yeah.
Actually, your field is really wonderful, and personally, I follow your chair. The things which is going in my mind that in the near future, we will plan to put all these things as a certification course and this swayam portal, so it will be broader audience.
So for education course, yeah, you also asked you have the same question, right? Okay, then we will discuss outside. So I will quickly answer it. So far, it's not designed to have a certificate course. It's more like if you have some interest, you are some student or teacher who needs some help. It's designed for that way. Once we have a good feedback on what to improve, then we can make it a course. Yes.
Good afternoon, everybody. My name is Ashish Mahavar. I'm from Caltech. But I'm going to talk to you today about how one could extend art to go to a dome. Some of you may have already seen these cards. QR code is also there. So we currently have it on our phones and our desktops. You can look at it. But I have changed the topic slightly. The last word was outreach, but this is something that what we are planning to do is you can also use this for citizen science. In fact, that would be one of the ways where we can be extended. We currently have it for the Wiki transit facility, but you can also use it with other surveys, with extensions. That's what we are planning to do. And again, extend it to many different ways. And one of the things that we are looking for is collaboration. So if you are interested, we will really work with you on that. Alright, how is astronomy changing? Things are really changing fast. In the last several years, we have gone to do many different sky surveys. And so what we have is surveys like the Wiki transient facility, Rubin, which is just about starting up in the southern hemisphere, Roman, which is going to be launched in September, and TESS, which has been looking at exoplanets for a few years now. What they have done is that the number of events that are being found is up by orders of magnitude now. ZTF finds of the order of 100,000 events. LSST is going to find of the order of million events. Roman, we exactly don't know, but it's going to look at objects that are up to 26th magnitude in infrared. So it's also going to be really different and lots of objects. Also in the galactic belt, so really large number of objects there. So what has become very important is going to machine learning. So with all this data, there's no way that individual humans can look at it. But at the same time, that doesn't mean that humans are completely out of the loop. There are many situations where we really need to have humans in the loop. They still matter, but somewhat differently. If you look here, these are numbers that I mentioned. So discovery today is not about these single spectacular objects, but entire families, and how do you go about doing that? So we start with data, do some machine learning, do some citizen science, and then machine learning on the data that has come from the citizen science, the neural networks that humans have helped us with. That is where things go forward. So humans are particularly helpful when the cases are ambiguous, when
it is the models that are not really sure about themselves. That's where our neural networks that have been honed on so much data, very different kinds of data that are really useful to look at patterns, etc. If the fields are crowded like these, it's easy to fool machine learning with this until it is trained better. So you start with training with simple things and then improve it in a big way. And then wherever there are borderline detections, what is it that is happening? And that's where you do. So this is a frame from Zard, for instance, where you have a light curve and we have something called wild classes in Zard right now. So we have posted classes, variable classes, and so on. But wild types are the ones where two different classifier thinks that that particular object belongs to them. And that is where humans can help us. Right now, again, Zard is only outrage, but when we get to citizen science, which should be soon, that's where it will really help us with. So this is how Zard today is. What you have are these different classes there. We show the science image, the reference image, how the difference there looks, and then the light curve. And there is some metadata, you don't have to go into that. But there are also some Easter eggs in that. So there are some very nifty things that we have put in which you can discover by going through the menus and so on. For catching each transient, you get some points. There are costs per object that you catch, and there are only a limited number of objects that you can catch. So you have to optimize your catching strategy for that. I won't go into details of that. We can talk later about Zard itself. So these are the fresh transients that we put from ZTF every night. Of the 100,000, we sparsify those and put a few of each kind, and that distribution is also available per night in that. This is a little bit like Pokemon Go. That's where we got this idea. So there are many different types. You pick a few, they are distributed over the sky, and so that's what you can try to keep on catching. There are many contributors, mostly undergrads. Some of them from IIT Gandhinagar, one from IIT Mandi, and some from Caltech as well. So they have been contributing to making this. And again, there are leaderboards, etc. As I said, I won't go into that because really what I want to come to is what we would like to do that with the dome. So Zard right now can be used in a classroom as competitive or independently, etc. You can use it with Android as well as iPhone or on a desktop also. And again, what can be done is that some source can be taken, it can be used for 1 month in a classroom. You can move on to another type of source and so on, so that can be an educational thing also. So what are the changes that will happen when we move to a dome? Right? A digital dome is essentially a hemispherical display, so instead of a phone or a desktop, that's what we are looking at. Phones become the input devices, so we want it to be interactive. It's not as if you just see it on a dome, but you should be able to interact with the dome using your cell phones. And the audience becomes a distributed classifier. So rather than an individual looking at things at a time, you can have 100 people simultaneously classifying an object. So what was shown earlier with, for instance, the 1 million galaxies, if you are shown a galaxy, if there are 100 people simultaneously with their phones, they could also show that. And then you will also be able to see what biases that they have, because you can have calibrated images where you're checking what is it, the knowledge that you already have and so on, right? So this removes essentially the need to author a traditional auditorium show. So you can have real-time data being streamed, and then you are looking at all those data, and it doesn't have to be a scripted thing, and things can flow in and do that in real time. So the earlier thing that I showed, that you go from data to machine learning to citizen science, what we can have is data to dome to audience phones, aggregation, and then dome and machine learning, and then that leads you to science. Right? So this is a loop where humans are very much in the loop dome. So a concrete example can be, I'm trying to look for real bogus. There is an object that has been found. I'm not sure whether it's astrophysical or not. So what I can do is that I can display it on the dome, and so you see something like this, and you're being asked, is it real or not? It could be bogus, it could be real, it could be a trivial description event. There can be multiple options. And then so this is what the phones have, and people can click on that. And as soon as they click, what can happen is that the live mode histogram can be displayed on the dome also. And then the ML confidence overlay can also come on that quite easily. And as you go to more and more complicated situations, you can also see how the learning is changing, and you can also divert it to, so if the algorithm is smart enough, and that can be built based on what kind of histograms are you're saying, you can go to simpler objects or more complex objects, because what you're trying to do in a very large dimensional space, you want to sparsify and understand where the distribution needs to be placed for getting human inputs in a proper way, because the simpler cases machine learning can do. But to make the harder cases simpler, we need to be able to define newer boundaries, and that is where again humans can come in really strongly. And why is this educational? Because disagreement is normal. So when if I ask all of you to classify something, there is going to be disagreement, and that's normal. So you would have seen those internet things where is it silver or blue or things like that, right? And that's again how our neural networks are processing. So a little bit of disagreements comes from the biases that we have, and a little bit of disagreement can come from what is actually being shown or how you tend to interpret things. And then science is in some sense provisional. There are changes that happen in science because we have certain models. Based on the models we understand something, but then we have to keep on changing things until we reach the right thing. So the changes are going to be there. And then the trade-offs become explicit when a large number of people are simultaneously classifying things. And that is why trying to get into this in a way will be very interesting. And so this teaches how science actually works, not just that it's not only how it's presented all the time. And this is also scientifically interesting because what this will do is that this will show us how human intuition works at scale. What are the edge cases where we expected something but humans tell us that no, this seems to be giving some other way. And also it creates training data for the future because these sets can be then written out, or these were classified in this way, those were classified that way, and so on. And now there are ways in which you can convert these data sets using various models like the Google cross-sum model into AI-ready data sets that can be dropped into Python tools, etc. So there is a lot of active learning potential that can be used with these data sets. So this is something that I wanted to pitch for something like the Mysuru Dome that is coming up, for instance, right? When this is an image from just a few days back. One can have an education-driven vision there. There can be multilingual audiences. The scale potential is huge because the room is fully digital. I believe it is 8K, so it's fantastic. So there's a chance to shape how digital domes are going to be used from day one since the planetarium is only coming up now. And what one could do is start with a very modest proposal, have a pilot proposal which works for 20-minute data flow. There can be a single task of classification. There can be one data set associated with that and a single dome. And then one can learn outcomes and see where this can go from there. This is very deliberately small, but achievable in that sense. So this is essentially an invitation on my talk that a student prototype is going to be developed. What we are going to have is there are a couple of students who will be working during the summer with me. One is going to be extending these things to citizen science in general. The other student is going to work on seeing how we can use this for a dome. So for a dome it's easy. What one can do is that one can have something like a Wi-Fi router and your phones can be connected on a local Wi-Fi and you can get specific inputs using your apps onto your phones and going into giving those inputs is very straightforward. So if people here are interested in doing something in 2026, let's join hands and see where we can go from there. I'll stop here, but happy to take questions. And I also have a few Zart badges like this. Come and talk to me and I can find a few. And there are these cards. Please take those, play the game, try it out, and see, give us feedback on the current version as well. Thank you.
Thank you so much, Ashish. So if you have any questions, we can have some. So Ashish is a great example of practicing scientists spending a lot of time in making this interface between outreach and his research work, of course. So you're also welcome to, I think, it's very accessible as well, so you can just talk with him or email him. And
I guess right now people are hungry.
I know. So that's great, and thank you for finishing in 10 minutes and giving us more time for. Yes, okay.
So is this already accessible for citizen science as such? Like, can we promote it to citizen
So
science?
right now, we can promote it to citizen scientists, but right now it is an outreach game. So what we currently have is that we do not seek inputs. Right now the classification is already being done. Even the wild types that we have, we know that those are somewhat misclassified by the models. But there is no way for people to tell us, okay, you are saying that this is wild type, but I know what it is. Right now, because what happens when you have citizen science, you need people who are receiving the data, acting on that. So that could be a fantastic collaboration, for instance, if there is a group here, for instance, the Aryabhat group has been doing something, or the Gujarat group has been doing something, and so on. So if they want to collaborate and say, we can be the back end where, yes, if we start receiving data, then they can do some analysis, or even the PKC group and so on. Then we can convert this very easily to citizen science, and we didn't make it citizen science just because we did not have human power on our side.
you have something? Great. Yeah. Please find him at lunch where we should head now. So thank you all for being a great audience as well. See you later at Chandrasekhar. No. Thank you. Okay, please check the schedule for where you can get.